Right now, roughly 60 to 70% of the Earth is covered by clouds. For satellites trying to monitor the ground, this creates a massive date gap, where more than half the planet is effectively hidden from view. Over India, this blind spot becomes a critical failure during the 3 to 4 month monsoon season. When logistics and disaster response teams are navigating flooded streets, they often face a total blackout of the satellite data they need to coordinate relief. Optical cameras are blocked by clouds. SAR penetrates weather, but produces abstract imagery. Agencies merge data from separate satellites, creating temporal misalignment. Since images are captured at different times, ground conditions shift, making accurate data fusion impossible. To bridge this gap, 5 engineers from IIT Madras founded GalaxEye. Their project, Mission Drishti, centers on the world's first OptoSAR satellite, a platform designed to capture both optical and SAR datasets simultaneously. Removing the time gap between sensors provides a persistent view of the ground. This allows operators to verify ground conditions in real time, even when heavy weather previously obscured the target. Combining these sensors created a massive engineering challenge: weight. The team had to shrink a historically heavy dual-sensor payload to fit onto a highly restricted 190-kilogram microsatellite platform. They swapped chemical propellants for an electric propulsion system, saving the 50% mass penalty usually reserved for fuel. They also utilized parallel engineering, co-developing the optical and SAR hardware as a single fused unit. This allowed them to integrate the systems from the start, rather than attempting to bolt separate sensors together after manufacturing. Even with the hardware miniaturized, raw SAR data is incredibly heavy. In a traditional setup, this creates a transmission bottleneck that delays processing on Earth and makes a real-time response impossible. GalaxEye used hardware-software co-design to solve this, integrating NVIDIA Jetson Edge computing modules. This allows the satellite to process complex data while still in orbit. By moving computation into the vacuum of space, the satellite processes its own imagery. This enables it to deliver ready-to-use insights with a 1.8-meter effective resolution without waiting for a ground station downlink. For deep tech startups, building independent aerospace testing labs is often a path to bankruptcy. The capital requirements for specialized infrastructure can drain a company's funding before they ever reach orbit. GalaxEye mitigated this risk through a public-private partnership strategy. They worked within the triple play of Indian space governance, leveraging ISRO for technical testing, InSpace for regulatory clearance, and NSIL for commercialization. The team followed a specific project management role: don't build what you can borrow. By using ISRO's established world-class testing infrastructure, they de-risked their R&D while keeping their capital focused on the technology itself. This lean approach led to a 2025 drone trial that captured India's most detailed SAR image to date. That milestone served as the minimum viable product needed to secure their $10 million Series A funding. Leveraging national infrastructure allowed a private team to innovate aggressively. They achieved space-grade results without taking on the financial burden of building their own physical testing facilities. The first Mission Drishti payload is scheduled for launch on May 3, 2026, aboard a SpaceX Falcon 9 rocket. While this first launch is a major milestone, the long-term roadmap focuses on building a fully operational 10-satellite constellation over the next 2.5 years. To reach that scale, the engineering team must shift their focus. They are moving from bespoke, one-off engineering toward an assembly line production model capable of rapid manufacturing. This constellation is a mathematical requirement to reduce revisit time. With 10 satellites in orbit, the network can provide near real-time monitoring of any point on Earth, ensuring that no location stays unobserved for long. The GalaxEye Playbook shows how agile startup development can be fused with national public infrastructure to build technical capabilities that were once restricted to major world powers. As these hybrid platforms target the global monsoon blind spot, all-weather tracking is positioned to become a standard utility. How will this level of data availability change the way your industry plans its logistics and infrastructure?